Today I want to chat with you about computer graphics and images, specifically the difference between bitmap raster images and vector images. So, why is this important? Well, even though computers get faster all the time and connections to the internet are blazingly quick, we always have the problem of latency and slow loading times when data demands of a connection are too high. Therefore, we always want to optimize our graphics and make sure we use the smallest file sizes we can while maintaining the best image quality. And you can't do that if you don't understand the fundamentals of graphic file formats and why we use them. And believe it or not, poor loading times can also reduce your relevance in search results. So not only is it a poor experience for the user because the page loads slowly, but users are less likely to even find your pages in the first place. Now, computers have dozens of image file formats, all with unique file extensions. All computer images can be categorized into two types: vector or bitmap raster graphics. In web development, we primarily use 4 image formats. There are 3 popular bitmap formats: JPEG, which stands for Joint Photographic Experts Group; GIF, which stands for Graphics Interchange Format; and PNG, which stands for Portable Network Graphics. Websites also use a vector format called SVG, which stands for Scalable Vector Graphics. So, how do bitmap and vector images differ? Well, in the simplest terms, vector images store data as a geometric mathematical calculation, whereas bitmap raster images store data as a grid of pixels. Now, you can also convert one format into the other. Converting vector images into bitmap is very easy and results in really nice images. Converting bitmap into vector is much harder and only yields good results if the bitmap image is very large and has an extremely high resolution. For example, imagine you have 2 images of a circle. One is bitmap, one is vector. In the bitmap image of a circle, the file will store the color and location of every single pixel in that image. As a result, the file size of a bitmap image is usually much larger than an equivalent vector. In the vector-based image of a circle, the file only stores 4 points at the top, bottom, left, and right of that circle, and it instructs the computer to draw a 45-degree arc between each of those points. As a result, the file size of a vector image is usually much smaller than an equivalent bitmap. Now, resolution is where bitmap and vector images differ the most. As I've taught before, the resolution of an image is a measurement of how many pixels comprise that image. Now, bitmap images, because they are comprised of a fixed quantity of pixels, they have a set resolution. So while the computer does have the ability to scale that size higher and lower through a process called interpolation, bitmap files always maintain a measurable number of pixels in that image. Vector images do not have a resolution. Since they are simply geometric shapes plotted through virtual mathematical coordinates, they can be scaled larger or smaller without any loss in resolution. You can see an example of this in the logo for this website. If we increase or decrease the size of the logo, it still looks great. One of the things I find extremely interesting about SVG images is that they're actually being rendered in a web browser using nothing more than source code. So, for example, if I just load up the Girls and Grandpa's logo here, and we actually view the source code on this page, you'll see that it is nothing but a whole bunch of coordinates, right? And this is all the coordinates that make up all of the lines in that logo. And here's kind of an interesting thing you can do. So if you go, let's say, to Developer Tools, right, and you actually come into the Developer Tools and you just start to randomly kind of delete this code, you'll see the logo changing, and you'll see parts of the logo starting to disappear. And that's just kind of strange. And I think it's kind of cool. It really shows, though, how an SVG image is being rendered in the browser with just all these different coordinates and all the colors and all that sort of thing. So kind of cool. It's kind of fascinating, and I think that's sort of a neat thing to understand about the way that SVG images function. And watch this. We refresh the page, and there you go. Everything comes right back to the way it was. Here's another good example of how I might use an SVG image. So I've designed my BMX jerseys in a vector-based program. And so I would create it as an SVG, and you can see here if I select different elements within the file, you can see all the little points and all of the pixels that comprise all these different elements, right? And then when I save the file, what I'll typically do is save it out as a PDF file. So right here is the PDF version, and you can see that if I zoom in really, really tight, we don't lose any of the detail, right? The image never gets pixelated. The lines are always very crisp and very clear, and you can always see everything. And that is the advantage of using a vector-based image instead of using a bitmap-based image. So the file size is also very small. As you can imagine, a jersey takes up a lot of space, right? The height and the width, it's a lot of room. So if this was bitmap, the file size would be enormous. But because it is all vector-based, the file size is really small. You can see right here, this is my Team USA BMX jersey, and it is only 218 kilobytes. So really small size for a really large graphic design. Let me give you another example of how I might use an SVG image. So I've occasionally done work for the banking industry, and right here is a good example of a credit union where here's their logo, right? And maybe I need a vector-based version of the logo. And it can be sometimes difficult to get those sort of things from a client, so you just want to try to get it yourself. And if I look here in Developer Tools, we can see that this is a PNG image, so that's not going to do. So how do you find a vector-based image from the website of a client? Well, you could, for example, come to the sitemap. See, if you're working in this kind of an industry, it's like, okay, the banking industry often has newsletters and things like that that are in PDF format. Now, PDF files can hold vector-based images or bitmap-based images. So let's take a look. Let's see. This looks like it's probably some kind of newsletter. Here we go. Yes, it is. And we check the link there. We can see it is indeed a PDF. So here we go. Here's their PDF file. And now let's zoom in to their logo and see what happens. Does the logo still look good and crisp and sharp, or does it get all pixelated? If it gets pixelated, we know that it's a bitmap. But if it stays crisp and clear, like it is right here, we know that it's vector-based. So we can download this PDF file, and then we can import it right here into a program like Inkscape, and click OK. And once this imports right here, now we can isolate just the logo, right? There we go. we've got just the logo. We can bring that over here. We can actually delete the rest of this, which maybe I shouldn't do because sometimes it takes an oddly long time. Okay, good. It didn't take a long time there. And then if we come down here, we can say resize the page to the selection. We can tell the document properties to show us the background, and then we can zoom into the full size. And there we go. Now we have a vector-based version of the logo, and we can just do a save as and save it as an SVG image. So very easy technique to create an SVG logo from a client's website, even though they're not really displaying an SVG on their website itself. Now, I know what you're thinking. You're thinking, well, if vector images scale up or down perfectly, why wouldn't we just use vector images all the time, right? Excellent question. When should you use a bitmap image or a vector image? What are their advantages and disadvantages? Well, typically, you want to use vector formats for images which contain solid colors and distinct lines, such as logos or infographics. Typically, you want to use bitmap formats for images which contain millions of colors and gradients, such as photographs or illustrations. Now, remember I said vector images plot lines and shapes and colors based on geometric coordinates. So as a result, a simple logo can have a very small file size. But if you were to plot all the millions of pixels in a photograph using the same methodology, the file size would be astronomical. This is why both formats exist. Bitmap formats create the smallest and most efficient file sizes for photographic images. Vector formats create the smallest and most efficient file sizes for logos and simple graphics. Personally, most every website I build tends to use nothing but SVG images and JPEG images. There are a few exceptions to that, but as a general rule, I stick to those two formats the most. Now, I told you the most common bitmaps for websites are JPEG, PNG, and GIF. But what are the differences between each? And when would you use one over the other? Well, in all honesty, I never use GIF images anymore. GIF images are bitmaps, but they can only produce 256 colors. Now, years ago, this made them ideal for logos and graphics and charts. But these days, SVG images are far superior since they scale so much better. And they also tend to have even smaller file sizes than GIF images. Now, JPEGs are great for photographs and illustrations. JPEG files use an algorithm to analyze and reduce differentiated pixels in an image and thereby compress the data into a very small size. Although JPEG images can be compressed down to extremely small sizes without losing any discernible quality in the image, when you save a JPEG image, be sure to preview the results of your settings because applying too much compression can create an ugly and blocky pixelization. When the compression is used sparingly, the quality is fantastic. Here is a really great example to illustrate that point. So this on the left-hand side is the original photo of a model named Renee that I photographed for the cover of one of my novels. And on the right-hand side, you can see a highly compressed JPEG version of the same image. And you can see this blockiness around the lettering. You can see how around in her eyes, how it's nice and clear on the left, but on the right it starts to get kind of blocky. And if we zoom in even tighter to, let's say, 400%, it becomes really obvious how the compressed JPEG has all of these squares in it of compression and all this artifacting like in her skin, and you don't see anything like that in the original image.
So that's why you shouldn't compress too much with a JPEG. You can see the original here is 6 meg. The JPEG is going all the way down to 42K. But we could still get a really nice looking image right here. There we go, we're at 171K, and they look pretty similar now. You don't see quite as much compression in the JPEG. So you can see that if you don't compress a JPEG too much, you can still get excellent quality and a much smaller file size.
Now, occasionally I'll use a PNG image when it's really necessary. The advantage of a PNG over a JPEG is that it allows for transparency in the image. So for example, I once used a PNG image of a television with a transparent screen, and I superimposed that on top of an embedded video to give the appearance of the video playing in the television set. So that was kind of a neat and fun way to use the PNG format, but other than a special use like that, JPEG images are really the way to go. So, now you understand the difference between vector images and bitmap images and when to use one over the other. It's a simple lesson, but a vital one in understanding the most optimal way to construct a website. And remember, kids, the world owes you nothing until you create things of value.